In this sample problem, we will encounter a combination of cut and fill in earthwork computations. By examining the given data, we observe that at station 9 plus 700, the vertical components are negative, indicating a fill condition. On the other hand, at station 9 plus 760, the vertical components are positive, which means the section is in cut. Now, let's proceed to the first requirement, which is to determine the area at station 9 plus 700. To do this, we begin by plotting the cross-section to better visualize the problem. First, we draw the grid and position the road base at the center. From the center line at 0, we plot the vertical value of -1.56. Next, we plot the right point with a vertical value of -0.53, and since the horizontal offset is not given, we temporarily denote it as x2. Similarly, we plot the left point with a vertical value of -1.84, and its horizontal offset is also denoted as x1. Then, connect the points of the vertical components to represent the ground surface of the section. Next, draw the trench by sketching lines from the left and right terrain points down to the corresponding edges of the road base width. Now, we consider the given side slope for the fill section, which is 1.5:1. Take note that the vertical component of the side slope is always equal to 1. If we analyze the left side, the horizontal distance from the edge of the road base to the terrain can be expressed as x1 minus 4. Using the concept of similar triangles, we form the equation x1 minus 4 over 1.5s equal to 1.48 over 1. Solving this, we obtain x1 as 5.776 meters. Applying the same procedure on the right side, we form the equation x2 minus 4 over 1.5 is equal to 0.53 over 1. Solving this, we obtain x2 as 4.795 meters. Now, we complete the horizontal distances of the terrain to proceed with the computation of the cross-sectional area. To determine the area, we divide the section into segments by drawing lines from the left and right edges of the terrain to the center line of the road base. We then label these segments as A1, A2, A3 and A4. Now, let's compute each segment. For A1, the equation will be equal to 1/2 times its base 4, times height 1.48. We obtain 2.96. For A2, it is equal to 1/2 times the base 5.776, times height 1.56. We obtain 4.5053. Then for A3, it is equal to 1/2 times the base 4.795, times height 1.56. We obtain 3.7401. And solving A4, it is equal to 1/2 times its base 4, times the height 0.53. We obtain 1.06. Adding all the segmented areas, we obtain a total cross-sectional area of 12.2654 square meters. And therefore, the answer for the first requirement cross-sectional area at station 9 plus 700 is 12.2654 square meters. For the second requirement, we need to determine the cross-sectional area at station 9 plus 760. Following the same procedure used in the first requirement. We begin by illustrating the section, drawing the grid and placing the road base at the center. Next, we plot the vertical components of the terrain. From the center line, the elevation is plus 3.50. At the right edge of the terrain, the vertical value is plus 0.70, and at the left edge, the vertical value is plus 1.085. Now, connect the plotted vertical points to represent the ground surface of the section. Next, sketch the trench lines from the left and right edges of the terrain down to the corresponding edges of the road base. Complete the horizontal distances in the unknown values, x3 and x4. The same solution procedure from the first requirement, use similar triangle equation, and using the given side slope, which is 1:1. For the left horizontal distance, the equation will be x3 minus 4.5 over 1 is equal to 1.085 over 1. We obtain x3 as 5.585 meters. For the right horizontal distance, the equation will be x4 minus 4.5 over 1 is equal to 0.70 over 1. We obtain x4 as 5.20 meters. Now, we complete the horizontal distances of the terrain to proceed with the computation of the cross-sectional area. To determine the area, we divide the section into segments by drawing lines from the left and right edges of the terrain to the center line of the road base. We then label these segments as A1, A2, A3, and A4. Now, let's compute each segment. Solving A1, the equation will be equal to 1/2 times its base 4.5, times height 1.085. We obtain 2.4413. For A2, it is equal to 1/2 times the base 5.585, times height 3.5. We obtain 9.7734. Then for A3, it is equal to 1/2 times the base 5.2, times height 3.5. We obtain 9.10. And solving A4, it is equal to 1/2 times its base 4.5, times the height 0.70. We obtain 1.575. Adding all the segmented areas, we obtain a total cross-sectional area of 22.8897 square meters. Therefore, the answer for second requirement is 22.8897 square meters. Lastly, for the third requirement, which is to determine difference in volume of cut and fill between the two stations using the end area method. To solve this, let's illustrate first the road profile of the two stations. Then, to determine the difference in volume, we need to subtract the volume of fill and cut. But first, we need to determine the location of zero volume section, denoted as x. To solve this, we may use similar triangle equation. Referring to the total triangle, which is area of fill plus area of cut over the total horizontal length, 60, is equal to area of fill over its horizontal component, x. Solving the value of x, we obtain a value of 20.9336 meters. Now, we can solve the volume of fill referring to the left side triangle using end area method. Area of the fill will be our A1 and the zero area will be the A2. Using the end area volume formula, which is equal to 20.9336 over 2, multiply them to 12.2654 plus 0. The volume of the fill is 128.3795 cubic meters. Now, the same solution procedure for the right side volume. This time, A1 will be the zero volume, then A2 will be the area of cut. Using the end area formula of volume of cut is equal to 39.0664 over 2. Multiply them to 0 plus area of cut, 22.8897. The volume of cut is then equal to 447.1091 cubic meters. Now, we can already determine the difference of volume cut and fill by substituting the values. Using the formula, which is the absolute value of the volume fill, 128.3795, minus the volume of cut, 447.1091, is equal to 318.7296. Therefore, the answer for the third requirement, the difference of the volume of cut and fill, is 318.7296 cubic meters. And that completes our solution. Always remember to carefully identify whether the section is cut or fill before proceeding with your computations. Keep practicing, and I'll see you in the next video.